GCSE level of AQA. So the first question that we are asked here is to draw a diagram to show how 1.5 volt cells should be connected in order to give a potential difference of 4.5. You need to understand that we have two types of connections, whereby we have parallel, also we have series. So if you connect cells in parallel, you are going to have the same amount voltage. But if you connect cells in series, it will mean that you are going to have a total sum. The total sum of all the voltage that you have will be equivalent to the number of cells that you have in that case. So in order to draw that, we need 3 cells in series. So this is all in the connection. So we are going to say if you have cell connected like that, we shall have a cell connected like that, we shall have another cell connected like that. So we end up having the 3 cells connected in that manner. So we are going to say that for us to achieve that, we need what? We need 3 cells like that. So which means that these cells are connected in series. Then we shall have that the longer side, this side is going to represent the positive terminal, and this is going to represent the negative terminal. So that's basically what you do in order for you to answer this particular question. Now, a student builds the circuit in the diagram below, and then you can see the current that is flowing through in this circuit is basically a current of 1.6 amperes. So which means that there is also a voltage supply of that, and we have 3.5 ohms well represented here. So how are we going to answer the questions in this particular part? Let's see the question that was asked here. We're going to see the question that was calculate the total resistance, and we are given the formula that resistance is equal to the potential difference divided by the current. So meaning the total resistance is going to be R is equal to the total voltage divided by the current I, and in this case the total voltage is 12 and the current is given as 3 point what? Let's see. No, the current is 1.6. 1.6. So if you're going to put that in the calculator so that we can be able to work it out, we are going to get our answer equivalent to what? 12 divided by 1.6, which translates to 7.5. 7.5 becomes the answer for this question. 7.5 ohms. So this is 7.5. Now the resistance of P is 3.5. Calculate the resistance of Q. So in order to work out the resistance of Q here, what you need to realize in this particular question is that these two resistors are in series, and if resistors are in series, the total resistance will be the sum of these resistors. So if we have gotten the total resistance is 7.5 in this circuit, then for us to get this resistance of Q, we are going to say it's 3.5 plus Q should give us the 7.5 that we got on the other side. So let's work it out so that the examiner can be happy. So this is going to be 3.5 plus the resistance of Q should give us 7.5. So which means that our Q is going to be 7.5 minus 3.5. If we subtract here, we are going to get 4.0 ohms as the resistance. 4.0 ohms. Already we cannot write this because already it's written here, so don't make that particular mistake.